Alrighty, this first problem says the particle's moving along the x-axis at time t, and this is the position function right here. So that's terrific. And we want to know when the velocity is increasing. Velocity is increasing where acceleration is greater than 0. So really we want to plug in this function and find the second derivative and find where the second derivative is greater than 0. So I go to my graphing calculator, to my y equals screen, and the first thing I'll do is clear out what I had in y1, and then I had something in y4 from my last problem. So now I just have in y2 and y3 the first and second derivatives. So I'm going to go ahead and type in my derivative function, my position function, x plus 1 times x minus 3, and that is raised to the third power. And basically I want where acceleration is greater than 0, so I'm going to not look at my position function, and I'm not going to look at my acceleration function, and I'm just going to look at my, did I say, okay, I meant I'm not looking at position, I'm not looking at velocity, but I will look at acceleration. Turns out these windows keep being the same for all different graphs, so that's helpful. I'm going to pause while it finishes graphing. All right, and it looks like acceleration is greater than 0 here, and then here off to the right. I believe this is at 1 and this is at 3. Normally I wouldn't assume that those are 1 and 3, but looking at the answer choices, they kind of have to be 1 and 3, and so my answer is D, t less than 1 and t greater than 3. So now let's do number 15. We have a cubic, which has a critical point at the point 1, 2 for one of these scenarios. So my critical point has to be where the derivative equals 0. The derivative is going to be 3x squared plus 2ax. And of course I'm setting that equal to 0, so I can go ahead and factor out an x to give me 3x plus 2a. And they want to know if my critical point, they want to know when my critical point's at 1, so I can go ahead and plug in 1 here. 1 times 3 plus 2a. Well, in order for this to equal 0, I need this factor here to equal 0. So that means that 3 plus 2a equals 0. So 2a equals negative 3, and a equals negative 3 halves. And so I know it's not this, and it's not this. So I'm either at a or d. And now I'm going to go back into my original function here, and I'm going to plug in a equals negative 3 halves. I'm going to plug in x equals 1 and y equals 2. So 2 equals 1 cubed, which is 1, and then 1 squared, which is 1, times a, which is negative 3 halves, plus b. That gives me 2 equals 1 half plus b. So b is going to be, let's see, let me do this again. 1 minus 3 halves is negative 1 half. I have to add that to both sides. So b is going to be a positive 5 halves, and my answer is A.